We're looking here at questions on what we call angles of elevation depression. So these are types of problems we can come across and need to use right angle triangle trigonometry. So what are we talking about? We talk about an angle of an elevation or an angle of depression. So imagine this is where you are. You're standing at a particular point, and that the horizontal is the straight line from your eye. So imagine that's your eye and you're looking straight out. The horizontal would be in line with your eye. So nice flat line, parallel to the ground. That's what we call the horizontal. And imagine you have to look up at something. So it may be a building, it may be a plane, it may be a bird, it might be the top of a tree. It could be anything. But that would be what we call that would be your line of sight to the object. So you're looking at up at some object there. What will happen is you create an angle there, and we call that an angle of elevation. So the angle of elevation is how we look from the horizontal up to our target, so our line of sight object. If we were talking about it's the angle of depression, so imagine you're on top of the building now. So you're on top of the building, you've still got a horizontal look straight out. But now you're on top of a building and you're looking at your friend who's down there on the ground. So what you would have is an angle of depression because it's going down. So the angle there, from the horizontal, is going down to your line of sight. But notice you can create in both situations, right angle triangles. And that's the whole aim of the process. Once we see our angle of elevation and our objects that we need to and our starting points, then we can form right angle triangles to try and solve problems. So let's have a look how this works. If we have a look here, firstly, we've got a situation where you've got a point. So you're on a cliff, and then you're looking at a point A here. So what we want to do is find the actual height of the cliff here, knowing that the angle of depression is 35 degrees, and that point A is 280 feet. So we're working in feet this time. Is that far away from the cliff itself. So what we look at here, we draw up a triangle. Let's just redraw that triangle. We've got our right angle there. That's 280 feet. So don't worry too much about working in imperial measurements. It's just a type of measurement. We've got the angle of depression there is 35. But if we look at the idea that those two lines are parallel because that's horizontal and so is that means those two would form alternate angles. So that gives us 35 degrees there, and that means that's going to be x at that point. So now we've got a right angle triangle to solve our problem. So we can say tan of 35 degrees here would be equal to the x over 280. And so x would be equal to the 280 times tan of 35 degrees. And get your calculator and substitute that put that into your calculator. And that would give you approximately, to the nearest whole number, 196. And again, that would be in feet. So that's how we start to find a side using our angle of depression. So again, once we get back to a right angle triangle, we can use SOHCAHTOA and we can work it out using any of the ratios. Having a look at our triangle here, we've got a triangle here with that's 18 and that's 15, and that's a right angle. We want to find the angle of elevation to the sun. So we want to find that angle there. Again, let's use SOHCAHTOA. We can see we've got the opposite, we've got the adjacent, which means we're going to have the tangent ratio. So tan of theta is equal to 15 on 18. And so to work out theta, that would be inverse tangent of 15 on 18. And we can throw that into the calculator again. And to the nearest degree there, that's going to give us 35 degrees when we work that out to the nearest degree. So again, every time we've got an angle of elevation depression, we've just got to interpret what it would mean and look like. Sometimes we'll get a diagram, sometimes we don't. So it's always best to draw up your right angle triangle. And that's what it's about, getting that right angle triangle. And once you've got your right angle triangle and all the data input in the right spots, you can get the correct ratio, set up your equation, then either set up your equation to solve your angle or for one of the sides.